state itself. So we are at 0, 1, and we go from 0, 1 to 0, 0. So we are going from 0, 1 to 1, 0. That's 2 bits change. So although the fundamental mode is in the input is working properly, the states are not changing in a way that only 1 bit changes at one time. So a fundamental mode is causing 2 bits in the state variables to change at the same time, and that's problematic.
So for cycles, you actually have to check every other state beside it?
Yes. Every one that's allowable under a fundamental mode operation. Yes. Don't check the ones that are not under fundamental mode operation, because that's an assumption we made already.
I don't know what about dynamic, but static is...
So let us, here we are at state 0, 0, and the inputs change from 0, 0 to 1, 0, which is a fundamental mode operation. That's acceptable. What happens? So we go from 0, 0 to 1, 0, 0, 0 to 1, 0, which means we go from 0, 0 to 1, 1 here. So although we have a fundamental mode assumption, which is working, the state variables, next state, will go from 0, 0 to 1, 1. 2 bits at one time. So we have a race. Is this race critical or not? So we look. We go, one possibility is to go 0, 0, 1, 0, and we are stable there. Or we go 0, 0, 0, 1, 1, 1, 1, 0, because that's the final step, and we are stable, because 1, 1 is going to take us to 1, 0, if you look at it, and 1, 1, 1, 0, 1, 0. So it doesn't matter the sequence the circuit takes, we will end up at state 1, 0, so therefore this is not critical. So question in the exam will be, look, can you determine if this circuit has critical race or no critical race and so on? Yes?
But you got to provide us what you're going to look for.
Huh?
Because you got to tell us like the specific check list. You had to check for everything. That's all of it. Yeah.
Okay. So you're saying that if I have to tell you for what possible input sequences, is that what you're saying? If I don't tell you, I have to do it for all possible scenarios, which is time consuming. Okay, good point. Okay. Again, analysis. You go back, the opposite, because we came up with the state variables, now we go back to the state names. So you can choose A, B, C, D as the state names and so on, okay? Design of asynchronous circuits. Is there any questions so far on the analysis?
Yes.
Yes.
Sorry, can you please go back and just show us one more time how to go from a state to a state? I can't exactly follow how you jump through the table yet.
Good. That's right?
Yeah.
Okay. So, assume that you are in a certain state. So when I say that I am in state 0, 0, that means I am here stable in state 0, 0. Now, I look at the input, and the input takes me from 0, 0 to 1, 0. So, which means it goes from 0, 0 here to 1, 0. That means my next state is going to be 1, 1. That right? You see that or not?
Yeah.
You see 1, 1 is the next state. The problem is when I go to 1, 1, I may not see the state variables changing from 0, 0 to 1, 1 at the same time. So what might happen? One of them is faster than the other. So the first one will go from 0 to 1 immediately, okay? And the other one is slow. So instead of going from 0, 0 to 1, 1, it goes from 0, 0 to 1, 0. So instead of going from 0, 0 to 1, 1, because it did not change the two variables from 0, 0 to 1, 1, it goes to 1, 0. But my input is 1, 0, so I go here. When I go here, it is a stable state, and the input is 1, 0. There is nothing that's going to force the circuit to go somewhere else. It just sits there. Is that right? So that's what we are showing here. Now, the other possibility, instead of going 0, 0 to 1, 0, it goes 0, 0, 0, 1, because this one was faster. You know, the most significant one, or the least significant one, was faster. So it goes from 0, 0 to 0, 1. So when it goes from 0, 0, here, to 0, 1, it goes to this one, but this one is 1, 1. So going now from 0, 1 to 1, 1, that's one state variable change. So it will go from 0, 1 to 1, 1. So this is just a transition, and it comes to 1, 0, and 1, 0, it comes to 1, 0, and it sits there. So it's the same value. So every time you go from present state to a next state, see what's in that next state, and follow it. Okay, let us take another example here. Look at this one, for instance. We are at state 0, 1, and the input changes from 0, 1 to 0, 0, from 0, 1 to 0, 0. And we are at 0, 1. So we were here, and then we change from 0, 1 to 0, 0. So what happens in that case? So remember, we are at state 0, 1, and the input changes from 0, 1 to 0, 0. So we have to go here, is that right? Which is, what is that? That's 1, 0, is that right? So when we go to 1, 0, in this case, when you look at 1, 0, so we are at 1, 0, 1, and this is 0, 0, it's going to take us to 1, 0. Where is 1, 0? It's 1 here, that's going to take us to 1, 1, and then we settle at 1, 1, and we are stable. You see what's happening now? So you just have to follow the arrows going through the different states. Now, I'm not going to go through the statement of the problem because I showed you how to interpret them. I'm just going to go through state reduction in asynchronous circuits just as another example. So this machine, as a matter of fact, we did cover it in the class. We just call it a different thing here. Remember the DG example? The DG example where we monitor the data and we make a decision as to keeping or producing a certain specific value. So it's the same thing here. So we went from the statement, and I will post this on the course website, and then we come up with these possible state diagram. And now we have the table here which represents exactly what we have here. We have A, B, C, D, E, F, and that's what we have. These are the different states. This is a flow table representation of the circuit. And we would like now to do some state reduction. State reduction has nothing to do with state coding, okay? So again, what I did here, I took away the ones that are conflicting already. For instance, A and D, they're conflicting, so do them first, okay? And then you look at the ones that you have and see if there's any condition you need to satisfy. So, if you look at A and B, they are okay. Is that right? A and B, A, C don't care, E, B, 0, 0. So that's why we leave them open, which is in my course notes. Sometimes I put them as a check mark, if you remember that. Okay, now when I go to B and C, if I consider them, they will be only equivalent if D and E are equivalent. Okay, so because when you look at B and C, look at B and C, you have A, and you have don't care, C, but you have E and D, so that's why one goes to E, one goes to D, that's why